Welcome to the session. Greeting of the day. In today's class, we are going to see about the various pneumatic actuating systems. We know we have seen in previous classes that in the actuating drive mechanisms, drive or actuating systems, we have divided into electrical actuating, mechanical actuating, then hydraulic actuating, and then now we are dividing into the pneumatic actuating systems. Now we are going to see about this pneumatic actuating systems and their few types. A mechanical device, a compressor is a mechanical device which converts a mechanical energy into a fluid energy, increases the air pressure by reducing the volume, which also increases the temperature. Here you see the same points: volume reduction, temperature increase of the compressed air, which is all done by the compressor component. After this we have cooler, after this the storage devices, after that the control valve, and then to the action. So I have taken one by one, we are going to see about the various types of compressors. Some few types of compressors are there, like piston compressors, double acting compressors, multistage compressors, so such diaphragm compressors. Those things we are planning to see in the now upcoming slides. First, I have taken a piston compressor. It is one of the reciprocating type. One I am dividing into displacement type. One is forward, and other it is forwarded action takes place. When the air is pressed here, the action takes place there. I am considering this as a forward or displacement compressor. I am naming this as a reciprocating compressor. So here the reciprocating action of a piston cylinder action takes place, coming in, coming out. Reciprocating process goes in and goes out. The goes in and goes out takes place. This I am naming this as a reciprocating type. On the reciprocating type, I have taken the piston compressor. You see here we have a crankshaft, and this crankshaft is driven by a motor. Here this driven by a motor, right? And then now when it is initial stage, it should come down. During coming down actions, it is a first stage one. It is going to take the inlet here, and then when it is reciprocating upward direction, it is going to pump out the force. With a high force, it is going to pump out, and it is going to open this spring returns, and it is going to come out that air outlet. So here we have the air inlet. A simple, very simple method of piston compressor. We have a piston operated to the electrical motors. The same type we have seen in the hydraulic systems also. Reciprocating fluid pump we have seen there. So reciprocating piston to compressor we are seeing here. So the same type, the medium is a fluid there. The medium is the air here. So it's a little bit similarities are there. Commonly used a pneumatic system. A pneumatic word I already told is a Greek word which represents the wind. A single cylinder compressor. Here we have used the single cylinder. Here we are using this a single cylinder actions. So it is a single acting cylinder. And then produces one pulse of air per piston stroke. This outlet, I am considering this as a one stroke, one pulse. Again it is coming down, again it is going back, it is a second pulse. Again it is coming down, again it is going back, it is a third pulse. For each pulse, for each stroke, I am getting a one pulse of air outlet. The pulse, the volume, the pressure rate different. I am not talking this how much pressure is going to. I am talking in terms of pulse. For one stroke, it is one volume, one output, one pressure, 10 bar is given. And next stroke, again 10 bar. Next stroke, again 10 bar. Likewise, it keeps on moving. For single cylinder compressor, gives a significant amount of pressure, pulses at the outlet. So this is capable of this single acting compressor, piston compressor is capable to develop the pressure around about 3 to 40 bars. So this is what about the piston compressor. Up to 40 bar of operation we can use this low level single piston compressor. If we need more pressure than this of more than 40 I should go to some other double actings or multiple compressors, reciprocating compressors are there. There we should move and go see. Here we are using a double acting compressor. Here immediately I am marking here the pressure which are higher than that of the 30 bar. Higher than that of the 30 bar. In previous slide we have seen about the piston compressor less 30 to 40. It is a starting stage. Now I need more than 40. We can use about this greater than 30 bars of double acting cylinder. So let us consider greater than 30 and also greater than 40. It is a 50 bar. With a single piston compressor cannot be used. Therefore, I am using this double acting compressor. What happens, you see, here there are few understandings are there. Here there are two strokes happening, the inlet and outlet. At the two times of stroke, the two pulses are generated. For each stroke, one pulse is generated, forward and return. At both time, we are receiving the outlet. Outlet is keep on coming. But we should understand what happening there. Therefore, I am understanding here as, see this setup, as usual the crankshaft driven by the motor. So here driven by the motor, and we have the crank and it is connected to the piston, and this cylindrical piston cylinder having some arrangements in such a way, you see here we have the inlet, here we have the inlet, and then here I have the outlet. Inlet air is going to receive, outlet air is going to come. How many times air is received, how many times air is coming in? That's the point. See, this point, inlet valves, outlet valves. There are two inlet valves. The air can come through this route. The air can come through this route. Two inlet valves. And simultaneously, air can take exit. It means this is the cylinder. Here the compression is going to take place. This zone the compression is going to take place. And then the air may come through this route, take exit. The air may come through this route and take exit. So there are two inlet valves, two outlet valves also, two are there. How it is doing there, you see. I have taken of like forward, of like one stroke is forward and one stroke is reverse. One stroke is forward and one stroke is reverse. Right. I am marking here as I1 as inlet 1. I am marking here as inlet 1. It is taken this portion as the inlet valve 1. I am writing here as a I1. I am writing this one as a I1. Again, this one, I am marking this as a I2. So I am marking here this is a I2. Later, the output 2 are there here. Again I am marking this condition as output 1, and again here also I am marking this as a output 2. So you can check here. Input 1, input 2. Output 1, output 2. Likewise I have marked. Now you see. At forward stroke, when I am pressing here, at forward stroke, this one inlet, the air is going to come here. So we can remove this first all, right? So all these things we will remove. You see here. Now it is okay. So this I have marked this as a output 2. Input 1, input 2, output 1, output 2. Okay. So this is output 1. What happens when the air is ready to come here? It is flowing here. The outlet is going to happen here. At one stroke of condition, one inlet and one outlet is going to open and close. Let us consider the forward action. I am writing here as the output 1, output 2. Now you see, when the inlet is coming, it will force. These valves are fabricated in such a way, when the pushing is happen from the top, it should comes down. Let us consider I2 is opening. It comes down. So it is opening here inside this piston. So I2 is open here. I2 is open. At the same time, it also opens here this oven. Is also open this oven. So oven is also open. What happens? At the forward stroke, this piston is going to push this zones of air which is already present there. So we are receiving this pressure at the outlet. Outlet has been taken from oven. But at the same time it is sucking inside. This is sucking the air inside at one condition. It is storing here. The air is stored here and it is going to compress. Air is stored here and it is also compressed. One stroke has happened. What is about the other two ends? Other two ends, this is only useful when the valve is going in this end. So it is closed now. Right? So now this I1 is closed and also I2 is closed. I2 is closed. Now, and the reverse, when it is coming back, O2 is going to open. When it is coming back, it is going to push upward and air is not going, but air can come in the downward direction only. So I2 is closed now. I2 is closed here. At the same time, O1 is also closed here. But here, when this reciprocating is coming, it will open this I2. This I2 is going to open. Here it is not open. Therefore, I2 is going to open here. And then simultaneously, I1 will also open to receive this inlet here. I1 is open to receive this inlet. So inlet is received here. Inlet is received here in such a way. Again, it is going to fill the air here. So this scenario has happened. I am taking the pressurized air. When it is forward, it is pressurized. When it is when it is coming back, it is storing the air. When it is forward, the stored airs are pressurized. At the same time, here when it is going forward, it is stored here. Left side, it is received through I2 and storing. When it is coming back, it is going to pressure and push and is going to take the outlet. So 2 inlet valves, 2 outlet valves. We are receiving outlet at the 2 stages. One is the forward stage, one is the reverse stage. At 2 stages, I am receiving the outlet. So it is more useful. Therefore, we are getting the pressure more than 30 bars. The pulsation of the air can be reduced by using the double acting compressors. So double acting compressors. It has a two set of valves. It has a two set of valves and the cross hole. And the piston moves. As the piston moves, the air is compressed on one side, while the other side, the piston, the air is sucked in. Here it is compressed and taken out. Here it is sucking inside. So likewise, both operation will take place. The air is delivered twice in the one piston. Air is delivered twice, important word. Air is delivered twice in one piston. Stroke. Pressure higher than that of the 30 bar. Now I am coming here with some multiple stages. We are increasing the pressure from the one normal piston to double acting. Now the multi-stage compressor used to reduce the temperature, compressed air during the compression. The inlet intercooling reduces the volume of the which is used to increase due to heat. The compressed air from the first stage enters the intercooler where it is cooled. The multi-stage compressor can develop a pressure of around 50 bars. So first we have seen less than 30, then above 30, here above around 50 we came. Now you see, in this setup, as usual, we have two cylinders, two connecting rods of pistons to operate. And I have a one inlet here, and it is going to come in, compressed, but again compressed, again I am taking the outlet. Double compression takes place and therefore high pressure, high 50 bars we are getting. First we have started to 10, 20, 30. Now we came. How it happens? You see, first inlet is coming here. This valve is kept below this zone. You see, it is straight. It is not permitting. And valve can open in the downward direction only. It cannot be moved upward when the piston is going again in this direction. So it can inlet only possible. But see here, this valve is operated in the above point. I am closing again the above point. So water can, this air can, when it is compressed, it goes through upward direction only. At the time, the air inlet is already blocked. Air is not going to reverse. It is going to go in this way. The compressed air, we told volume is reducing and temperature is increasing. So the increased temperature is going through, this increased temperature, increased air is going through this route. Is going through this route. And here we have a cooler. It means somehow heat exchangers. And after heat exchanging, what it is, we have here like this. Some heat exchanging devices, some water transfers. Therefore, heat is heat exchanged here. And then now the normal conditions will come. Normal, this temperature reduced compressed air will come here and is going to take the inlet. Here, as usual, the valve is at the outside. It means it only permits downward direction. It is not going to permit in the upward direction. Reverse not taking place. So it comes here. Here also again the compression takes place by this cylinder pistons and it is compressed back again here. This cylinder only permitted up in the upward direction. So it is permitting in the upward and it is a compressed air. So it is compressed back to the outlet. So this is the second stage compression. First stage compression. Here it is mentioned as a low pressure compression. After again when the second stage compression takes place, it is getting higher pressures around 50 bars. Around 50 bars we are getting this on the multi-stage compressor. This is one. Now we go to the another multi-stage compressor, maybe this type also. We have two pistons here. It looks single. You see, two-stage compressor is carried out by using a same piston. So with same piston, with a double diameter piston, but it is nothing but a double diameter piston. One contains is this one is one. I am considering this as a main. I am considering this is a main piston, a large one, and I am considering this one as a second one. This one as a second one. This is a first one. So second piston. So according to this diagram, you see this piston second can able to occupy this place, and then when the forward stroke is applied, the main piston can able to occupy this spaces. It means this spaces. This spaces can be occupied. So two stages are happening. One stage at this in valves and one stage at this valves is happening. So this can able to operate here and this can able to operate here. Now we come. Inlet where I will take. I am taking the inlet. Inlet is air received, sucked back. So it is sucking in. This valve at the downward direction only permits. Only is going to permit. So here, this is the downward. So air is only permitted here. It came. Now air is filled here. Air is filled here. And then when it is compressed back, here also it goes. It is a cycle. You see, it is a cycle. First, it is at zero. It is okay, but when it is cycling, we are getting a double compression here. You see now, air is filled here. I'm coming from this side. Now this valve will permit only in the upward direction, and this goes here. It flows through this way. Temperature is increased. Therefore, here we have a heat exchanger. Therefore, lightly again I am converting this travel and it comes here, right? And it is this valve compressed air. We have only comes down, permits only downwards. So again it comes downwards. Now this is occupied here. This is occupied here. This occupied there. When this cyclic process happens, the piston is going to have a position here, and this stage 1 compressed air is going for the stage 2 compression through this piston action. So what happens? Again the stage 2 compression will take place here. Again the stage 2 compression will take place here. After stage 2 compression, it is going to goes out through the outlet, which only this valve permits the outlet in the upward direction. So this is going to take place here, and we are getting the output, a pressurized air more than 50 bars. So likewise we can able to do this multi-stage pistons compression action. A two-stage compression is carried out by using the same piston. Initially, when the piston moves downward, it means it's going downward, it's sucking in, the air is sucked in. Piston is moving downward, air is sucked in through the inlet valve. Yes. During the compression process, the air moves out. During the compression process, the air moves out of the exhaust valve in the intercooler through the exhaust valve to the intercooler. As the piston moves further, as the cyclic is keep on further, the stepped head provided on the piston moves. The stepped head, this is a stepped head given over the piston, moves on the cavity, moves on this cavity, and thus causing the compression of the air. So likewise we understand this double stage compression takes place. The summary. In today's class, we have seen about the various types of pneumatic systems, the various components of pneumatic system, and also we have seen some of the types of compressor. Likewise, a piston compressor, likewise a multi-stage compressor. The remaining part of the subjects we'll see you in the next session. Thank you.